So the rational functions that we've been talking about up to this point were very similar to their parent functions. The a value obviously changed your branches from either first and third quadrants or second and fourth quadrants, or that a value, depending on that absolute value, would move the hyperbola further and further from your axes. But right now we're going to talk about rational functions and their translations. So in front of you, I gave you an example, y is equal to 2 over x minus 4 plus 5. And we're going to talk about how the minus 4 and the plus 5 changes your original function and shifts it according to what those values are. So to start out, the numbers with x, so the numbers that are paired with x, which in this case would be the minus 4, in the denominator, makes your graph move opposite what you think it will, so opposite of its symbol, and it moves left or right according or very similar to your x-axis. So since your x-axis moves left or right, that minus 4 means you're going to be moving opposite of what you think it's going to. So that minus 4 means you're actually going to move your graph right 4 units. So the minus 4 in this example means from your original rational function, your parent original function, you're actually moving 4 units to the right. The numbers added or subtracted outside of your x, so the outside piece. So in this case, it's going to be the plus 5. This correlates or coordinates with your y. And since your y-axis moves up and down, the plus 5 is actually going to stay as is. It's not going to be opposite, and it's going to move up or down. So because it's plus 5, you're actually going to move your graph up 5 units. So your original parent function, or your original function that you're going to start off graphing, and we'll talk about this in example 2, 2 over x, we get rid of the pluses and minuses, that's your original. So if that's your original graph, the minus 4 with the x and the plus 5 outside with your y moves this original graph right 4 units and up 5 units. With that being said, that also means that your horizontal asymptote, because your horizontal asymptote, again, remember, runs like the horizon, is your x-axis. The way that you're moving up 5 units means that your horizontal asymptote is also going to move up 5 units. So your horizontal asymptote, if you remember from your original function, your horizontal and vertical asymptotes were your x and y axes. Your horizontal asymptote, because you're moving 5 units up, is actually going to be y is equal to 5. That's going to be your new horizontal asymptote. Your vertical asymptote, again, so you're moving 4 units to the right. Your vertical asymptote straight up and down, because you're shifting 4 units to the right, is going to give you a new horizontal asymptote of y is equal to 4. And we'll talk about that a little bit more in this next example. So in example 2, they want us to graph the equation y is equal to 10 divided by x plus 3. Then they want us to state the domain and range. So step 1 is going to be drawing our asymptotes. So right off the bat, I'm going to write down a couple things that I expect. So the first thing I expect is for my graph to move 3. So since it's paired with my x, I know I'm moving left or right. And because it's with my x, I know it's going to be opposite of what I think. So since it's plus 3, it's actually going to move 3 units to the left. So that's what I'm expecting my graph to do. So the first thing I'm going to do is draw my asymptotes. So since I'm moving 3 units left, I know that my vertical asymptote is going to be the asymptote that is going to be shifting. So my vertical asymptote, which normally would be my y-axis, is going to be moving 3 units to the left. So my vertical asymptote, my new vertical asymptote, is going to be x is equal to -3. And that's one thing that we want to make sure we understand. So vertical asymptote, because I'm moving 3 units to the left, that's going to also shift 3 units to the left. So I'm going to take my marker or highlighter. 1, 2, 3. and draw my vertical asymptote. Because I'm not moving up or down at all from my example above, because I have no plus or minus outside of my fraction, so to speak, I know that my horizontal asymptote is not going to shift at all. So I know that's going to continue to be my x-axis or my y equals 0 line. So when I make that horizontal asymptote, I'm going to highlight still my x-axis. So those are my two asymptotes where I know my graph is never going to cross. In step 2, I'm going to plot a few points. So I want to pick nice numbers if I can. I'm going to try. I'm just going to write that down. Try to pick nice numbers that correlate with 10 being in your numerator. So a couple numbers that I picked ahead of time, and I'm going to write them kind of in a row. I picked -5 as being a nice number because -5 plus 3 gives me -2, and 10 divided by -2 is equal to -5. So if I plug in -5 into this equation, I get a -5 back out. Another nice number is actually -4, because -4 plus 3 gives me a -1, and 10 divided by -1 is obviously -10. Play around with a couple more numbers. I think -2 is a good number to plug in. -2 plus 3 is a +1, so 10 divided by 1 obviously is 10. And I also picked the number -1 because -1 plus 3 is 2, and 10 divided by 2 gives me 5. So in this case, I got two nice numbers, or a total of 4 numbers that I can plot that will give me an idea of what my branches are going to look like. So -5 minus 5, 1, 2, 3, 4, 5. -4, -10. And then if I move to -2, +10, and -1, 1, 2, 3, 4, 5. I can kind of connect these numbers. It's always nice to get 3, but in this case, because you know basically what your graphs are doing, it gives you an idea of where those branches are going to be. You know that you're going to be in quadrants 1 and 4. That also matches the fact that you have a +10, positive A value, so you still have your positive slope, so to speak. But you have your 2 branches. Now they're not exactly in a quadrant, but it still is kind of in the quadrant if you look from it in terms of how your vertical and horizontal asymptotes divide your graph. So step 3, we want to draw the branches of the hyperbola, which we just did, and now we want to talk about the domain and range. So your domain and range, like I said in example 1, is going to have some type of relationship that that kind of coordinates with what step 1 is, what your asymptotes are. So your domain and range have some type of relationship with your vertical and horizontal asymptotes. So in this case, again, my domain deals with my inputs or my x's, my range deals with my outputs or my y's. So if I look at my x, which is left and right, I have a graph from this point forward, and I have a graph for x from this point to the left. What I don't have a point for is for my x value when x is equal to -3. So I know that x cannot equal -3. At the same time, I have y values that are positive for my graph, and I have y values negative for my graph, but what I don't have is a point at y equals 0. So I know for my range, y cannot equal 0.